Good day guys, this is your tutor engineer. Today we'll be doing an exam question on a cubic function, grade 12. So let's start. The graph of h is drawn. The graph has a turning point at 0 and b. A is the x-intercept. So we've got all the 3 points as on the statement. The first question is, show that a is -1 and b is 6. Okay. Now, remember we've been given the graph of h, which is 8x cubed plus bx squared, and we have got point B. Point B, x is 4, y is 32. So let's replace y by 32 and x by 4. So this will give us a 32. 4 cubed is 64. A plus 4 squared is 16b. So let's further simplify this by dividing every term by 16. So this will give us a 2. I believe this will give us a 4. A plus b. So let's call this equation 1. Again, b is the turning point, which means at the turning point you can get the first derivative and equate it to 0. So the first derivative is h prime of x will be 3ax squared plus 2bx. Then you say that's equal to 0. We know that point B has the value of x, so the x coordinate is 4. So instead of x, we'll replace x by 4. That's equal to 0. Then you can further simplify it by saying 3 times 4 squared will give us 48. A, and then 2 times 4 is 8b. That's equal to 0. So we can again simplify every term by dividing it by 8. So 48 divided by 8 will give us a 6a plus b is 0. I want to write it in the same format as equation 1, so I can rewrite this as 6a plus b, and then I can name it equation 2. So in order to solve 1 and 2 simultaneously, I will say equation 2 minus equation 1. So I will say 0 minus 2, I'll get a minus 2. 6 minus 4, I'll get a 2a. b minus b will give me just a 0. And then from here on, I can just divide by 2, find that a is -1. Then in order to get a b, I can either use equation 1 or 2. I will use equation 2. A, I know that it's already 1, then b. Then -6, I'll take it to the right hand side. On the left hand side, it will be positive 6. Then I know that b is 6. So that means the new equation for h of x with all the values known is going to be minus x cubed plus 6x squared. So a is -1 and then b is 6. Then the second question is calculate the coordinates of a. A is the x-intercept. So really at the x-intercept you say y is 0. So I'll say y here is equal to 0. And then I'll have minus x cubed plus 6x squared. Then I'll solve for x from here. Take out the common factor. Minus x squared is common. Then I'll divide here, I'll get an x. Then dividing it there, I'll get -6. Then this is minus x squared is 0, or x minus 6 is 0. So if I solve here, I'll find that x is 6, which is really going to be the x coordinates of a, and then the coordinates of a is 6 and 0. Now let's go to 10.3.1. Write down the values of x for which x is increasing. So you'll notice that this is 0, 0. X is increasing from when, or the graph of h is increasing from when x is 0 up until when x is 4. the graph is going up. So we'll say here x is less than or equal to 0, or x is less than or equal to 4. Then the values of x for which the graph is concave down, you'll notice that the graph is concave up until the inflection point over here, and then from there on it's going to be concave down. So in order to determine the value of x, we need to get the value of x at the inflection point. So the way we identify the value of x at the inflection point, you get the first derivative first of the graph of h, which is going to be minus 3x squared plus 12x, and then you use this formula. After you have your first derivative, x is equal to minus b over 2a. B here is 12, then a is minus 3. So where there is a, I'll replace it by minus 3. Then I'll get minus 12 divided by minus 6, which is just 2 here. X is equal to 2. That means the value of x there is 2. Therefore, I can conclude that the graph of h is concave down when x is greater than 2 and less than or equal to positive infinity. So I will say x greater than or equal to 2 and less than positive infinity. And then the last question is, for which values of k for which this graph is equal to 0 have the negative and 2 positive roots. So this looks like our original graph, only that it shifted to the right by 1 unit. So let's name it the graph of y and find the y-intercept for this graph. Since the k doesn't have x, so k is part of the y-intercept. So y-intercept, I'll set x is 0, cube plus 6, 0 minus 1, that's minus k. So minus 1 cube is minus 1. Sorry, there's a square here. 6 minus 1 squared is 1 minus k. So that's really y is equal to 1 plus 6 minus k, which is 7 minus k. That is the y-intercept of this graph. So that means here the y-intercept is over there, 7 minus k. The graph looks something like that. It only shifted to the right by 1 unit. So that will be our new graph there. And from here on, let me just change the color to orange. So in order to get the value of the value of k for which the graph satisfies the negative roots, that means this will have to shift down by until it is cutting here at 0. So I'll shift this graph further down to get to the top value of my graph. So it's going to look something like that if I do it. So I'll say 7 minus k will be less than 0, for which I'll have the negative roots, right? So, and then if I shift this graph further down, like it was, okay, I didn't do justice here. It should have gone, I shifted it down, okay, I shifted it to the right by 1 unit, so, and then I shifted it down by 7 units. So by now it is going something like, there's a new value here at the turning point. Okay, the turning point, yeah, sorry about that. Let me just fix something here. The graph is supposed to look something like this. The turning point already here, it's down by 7 units, so it's 25. Since my focus is really here on the y-intercept, this is 7 units, and then if I shift this further down, that will be minus 25. So that means I'm really looking at the lower point of the graph. That's going to satisfy my condition, and it will just turn there at the x-axis. I'll still have 2 positive roots and then 1 negative roots. So I'm really interested in this part of the graph. So here I'll say I'll have a minus 25. 7 minus k has to be between minus 25 and 0. So looking at this left hand side, we'll have minus 25 is less than 7 minus k. Taking 7 to the left hand side is equal to k. So that's minus 32 less than or equal to minus k. So if I multiply everything by minus 1, I'll have 32. Then I will flip the equality sign, and then I'll have something like this. And then on the right hand side, this part here is 7 minus k is less than or equal to 0. I'll just take k to the right hand side. Therefore, if I were to write in one way, k here is less than 32, and then k is greater than 7. This will be the answer.